From this video lecture, we are going to start with Riemann-Stieltjes integrals. And this is chapter 4, which is starting with complex integration. And these are the fundamentals of the area of the study of analytic functions. And they constitute one among the fundamental pillars of mathematics and they have large applications. So let's start with how to define a bounded variation as well as a total variation. And then we'll just move on further into the topic. So in this lecture, we will see how we can define bounded variation and total variation. So firstly, we need a function which is gamma and it is coming from a closed interval AB. This closed interval AB is a subset of the real line, okay, and it is simply said that it is a function. It does not imply that it is continuous or not or not any other properties are given for this gamma. It is simply a function, okay. So a function, such a function into C is called a bounded variation if there is a constant capital M strictly greater than 0 such that for any partition P which is actually partitioning our closed interval AB, that is, suppose if this is a closed interval AB, this is partitioned into small subintervals. Okay, so these subintervals are nothing but uh, t of t0 t naught. See, this closed interval AB is partitioned as like this: t naught t1. We are having subintervals like this: t1 t2 etc, and the end is tm minus 1 tm. Okay, and we are calling T naught to be A and Tm to be B. That's what we are saying. And this is the partition. What we just said is called the partition. It's called P. So there is a denoting, we denote a partition like this. The set T naught strictly less than T1, strictly less than etc, strictly less than Tm, which is equal to B of closed interval AB. Okay. Now, this gamma is called of bounded variation if V of gamma P, it is just a denotation. We are denoting it, this sum like this, okay. That is less than or equal to M. So what is this? That is equal to the summation K is equal to 1 to M gamma of Tk minus gamma of Tk minus 1. We said that we are having these partitions like this, right? And we know this gamma is happening from closed interval AB to C, right? So definitely there will be gamma of T naught, gamma of T1, gamma of T2, etc., gamma of Tm minus 1, gamma of Tm, or are all are well defined, right? So we can calculate and they are happening inside this complex plane. So this we are taking gamma of T1 minus gamma of T naught, the modulus, plus gamma of T2 minus gamma of T1 plus etc, and it's going like that, plus modulus of gamma of Tm minus gamma of Tm minus 1. Okay. So this is the sum, and the sum is written in the notation like this: summation k is equal to 1 to m modulus of gamma of tk minus gamma of tk minus 1. Or definitely we are taking modulus because we are dealing with complex numbers. So in order to have the sum which is less than or equal to m, we need to take the modulus. Then only we get a real number. So that is equal, that is less than or equal to m. That's what it said. Okay. So if this sum is less than or equal to m, we can say that the function gamma which we define from closed interval a b to c is a bounded variation. Also, we call total variation of gamma and define it as v of gamma, and it is defined as the supremum of all such v of gamma p where P is a partition of closed interval AB. That means we have to take every partition of closed interval AB and find their corresponding uh, the sums sitting here, and we have to find the least upper bound of all such sums. Okay, and that is called V of gamma, and V of gamma is definitely less than or equal to M. That means because always the sum will be less than or equal to M, right? So definitely the least upper bound will be also less than or equal to m, and that is strictly less than infinity. Okay, because that is strictly less than infinity, since we know that this m is a real number. Every number is happening to be strictly less than m. So definitely that will not take a value infinity. So that is what is called a bounded variation and total variation. So thank you for watching out. So let's see in the next video lecture how we can deal with preposition 1.2 and 1.3 and so on in the Riemann stages integral section. So thank you again.